Solid-state batteries are currently generating a lot of excitement, touted as a transformative technology that could revolutionize electric vehicles and portable electronics. But do they truly live up to the hype? The situation is complex, though a recent development from TDK Corporation, a major player in the electronics field, could shift the conversation. They have introduced a groundbreaking material for solid-state batteries with an astonishing 100 times the energy density of existing alternatives. The quest for a powerful solid-state battery is not a solitary endeavor. Major car manufacturers, particularly those from Japan, have been vocal about the immense potential of this technology. Toyota, for instance, has been heavily invested in in-house battery development and aims to bring solid-state batteries to market by the end of 2027. However, this target date has shifted from earlier projections, highlighting the unforeseen challenges encountered when scaling up this new technology from the lab to mass production. The mechanical complexities involved in building large, robust, solid-state batteries for electric vehicles have proven to be a significant obstacle. This advancement could be game-changing. Imagine electric cars with vastly extended ranges on a single charge, or smartphones that last for days without needing to recharge. It is an intriguing prospect, but there is much more to consider. How did TDK achieve this? And what does it mean for the electric vehicle sector? Let us delve into the details and explore the future of solid-state batteries. A new type of battery design called semi-solid state has emerged. This technology offers a stepping stone towards the ultimate goal. Chinese automaker NIO exemplifies this approach, offering semi-solid state batteries as an option on their ET7 sedan. Semi-solid state batteries boast an impressive advertised range of 1,000 kilometers, a significant improvement over current electric vehicle offerings. The development of solid-state battery technology is a race against time, with companies like TDK and car manufacturers like Toyota vying to be the front-runners. While technical hurdles remain, breakthroughs like TDK's new material and the emergence of semi-solid-state batteries offer a promising glimpse into the future. We are on the cusp of a transportation revolution, with electric vehicles powered by safe, long-range solid-state batteries becoming a reality. This shift has the potential to drastically reduce our dependence on fossil fuels and pave the way for a cleaner, more sustainable future for our planet. So, when should we expect to see TDK's new battery in the market? Well, the road to widespread adoption of solid-state batteries is, honestly, pretty complex. TDK has developed a new type of battery technology, a solid-state battery. Unlike traditional lithium-ion batteries that use a liquid electrolyte, solid-state batteries rely on a solid material for their internal workings. The solid-state design really holds the key to the breakthrough here. TDK's innovation boasts a massive leap in power compared to their previous attempts. Just imagine a car battery that acts like a supersized gas tank, allowing you to travel much farther on a single charge. This new battery packs a whopping 100 times more energy than its predecessors. Placed inside a smartwatch, the new battery could keep a device running multiple times longer than current battery technologies. The Apple Watch currently lasts up to 72 hours in low power mode before it needs recharging, meaning it could potentially last several weeks with an improved battery life. Other potential applications beyond wearables could include environmental sensors. According to TDK, while the initial application of this technology targets smaller devices like headphones and smartwatches, the ultimate goal is to scale it up for electric cars. With this powerhouse battery, electric vehicles could potentially travel a staggering 1,500 kilometers or 930 miles on a single charge. That is more than 3 times the range of most EVs on the road today. This significant improvement would drastically reduce range anxiety and make electric cars a far more appealing option for drivers who frequently travel long distances. The benefits extend beyond just range. Solid-state batteries boast a safety advantage because they eliminate the risk of flammable liquids present in traditional lithium-ion batteries. Additionally, they may offer much faster charging times, significantly reducing the time spent waiting at charging stations. However, the path from groundbreaking innovation to widespread adoption is not always smooth. Unlike conventional lithium-ion batteries that use a liquid electrolyte, TDK's solid-state design relies on a solid ceramic compound made of oxides. This solid ceramic acts as a bridge for lithium ions to flow between the battery's two components, the lithium alloy anode and the cathode. While the solid approach offers significant advantages, it also presents some technical hurdles. Maintaining a stable connection between the solid electrolyte and the electrodes proves more challenging compared to liquid electrolytes. Additionally, the entire battery needs to operate under pressure, adding another layer of complexity to the design and manufacturing process. One analysis highlights a potential niche where solid-state batteries could offer a significant advantage. Electric-powered heavy trucks, for example, may not be well suited for lithium-ion technology due to the limitations on range and charging time. Solid-state batteries, with their potential for longer range and faster charging, could be a game-changer for the electrification of heavy-duty vehicles. Solid-state batteries are considered safer due to the absence of a liquid electrolyte, which is a potential fire hazard in traditional lithium-ion batteries. The use of solid materials in the battery's construction enhances its stability and reduces the risk of thermal runaway, making it a more reliable and secure option for powering electric vehicles. The primary challenges lie in manufacturing and cost. Scaling up the production of these sophisticated solid-state cells to the volumes required by the global automotive industry is a monumental task. The specialized materials, such as the solid ceramic electrolyte and the precise, pressurized assembly processes, are currently expensive. For solid-state batteries to become a mainstream reality, companies must develop innovative and cost-effective manufacturing techniques that can reliably produce millions of these units. This will require significant investment in new production facilities and equipment, a process that takes considerable time and capital. Furthermore, the integration of these batteries into existing electric vehicle platforms presents its own set of engineering challenges. The different physical and chemical properties of solid-state cells compared to lithium-ion batteries may necessitate a complete redesign of battery packs and the thermal management systems within a vehicle. Automakers and battery producers will need to collaborate closely to ensure these new power sources are not only powerful and safe, but also compatible with the structural and operational demands of modern cars. Despite these hurdles, the pace of advancement is accelerating. The announcement from TDK has injected renewed optimism and competition into the field. Other companies and research institutions worldwide are also reporting progress with different solid electrolyte materials, such as sulfides and polymers, each with its own advantages and challenges. This diverse research landscape increases the likelihood that a viable, mass-producible solution will be found. The timeline for widespread availability remains a subject of debate. While initial applications in small-scale electronics like wearables and headphones are expected within the next few years, the deployment in electric vehicles will likely be more gradual. We may first see solid-state batteries in limited production, high-end luxury vehicles, or in specific commercial applications, like the heavy trucks mentioned previously, where the higher cost is more easily justified by the performance benefits. A broader rollout to mainstream consumer vehicles is more probable towards the end of this decade or in the early 2030s. In conclusion, while the journey from laboratory breakthrough to a battery powering your family car is long and, honestly, fraught with challenges, the potential reward is just too significant to ignore. Solid-state batteries represent more than just an incremental improvement. They promise a fundamental shift in the capabilities of energy storage. The recent progress signals that the industry is moving closer to turning this promise into a practical reality, paving the way for a new era of electric transportation and clean energy utilization. The potential impact of TDK's breakthrough extends beyond individual consumers to the automotive industry as a whole. Car makers have been striving to overcome consumer hesitance towards electric vehicles, particularly among those who rely on their cars for long journeys. By offering a solution to range anxiety and enhancing the overall performance of EVs, solid-state batteries could be a game-maker in the push towards sustainable transportation. In recent years, there has been a growing emphasis on transitioning towards cleaner and more efficient modes of transportation to combat climate change and reduce reliance on fossil fuels. Electric vehicles have emerged as a promising alternative to traditional internal combustion engine cars, offering lower emissions and reduced environmental impact. However, widespread adoption of EVs hinges on addressing practical concerns such as driving range and charging infrastructure. The development of solid-state batteries represents a significant step forward in overcoming these challenges. By enabling electric vehicles to travel longer distances on a single charge, solid-state batteries could make EVs more appealing to a broader range of consumers. This could lead to a substantial reduction in greenhouse gas emissions from the transportation sector and contribute to global efforts to mitigate climate change. Beyond the realm of personal transportation, the implications of TDK's solid-state battery breakthrough extend to various other industries. The potential for higher energy density and faster charging times opens up opportunities for innovation in portable electronics, renewable energy storage systems, and even aerospace applications. The versatility of solid-state batteries positions them as a key enabler for advancements in multiple sectors, driving progress towards a more sustainable and technologically advanced future. TDK envisions their newly developed solid-state battery material playing a pivotal role in a large-scale shift towards a more sustainable and energy-efficient future. This technology has the potential to revolutionize the way we power our society. However, the path from groundbreaking innovation to widespread adoption is not always smooth.